often called combining like terms. Basically, what it is combining things that match. The first thing we need to do is identify what are called terms. This is a term, this is a term, this is a term, and this is a term. We earlier in the year said that monomials are single terms, binomials are two terms, trinomials are three terms. A term is just separated by addition and subtraction. So in this particular problem, there are four terms. Each one of those are terms. We also have what are called coefficients. Coefficients are the numbers in front of your variables. So the coefficient of our x here is 2. Our coefficient of this x is 1. It's the number that's the number of x's. So our coefficient of x here is 2. Our coefficient here is 1. So we have four terms, and our coefficient is the number in front of our variables. Looking at a few different examples of actually combining like terms, what we can do is look at, let's say, 6a plus 2a. When you look at the variables, your variables are the same. This is telling us I have 6 a's, and then I'm adding 2 more a's to it. So when I do this, all I have to do is add the coefficients. I have 6 a's here, I have 2 a's here, so how many a's do I have altogether? 8 a's. Very good. So you have x plus 9x plus 3. Now your variables are not all the same. They're actually changing a little bit. Think of it as the blue pawns and the number cubes. So I have a blue pawn, and then I have 9 more blue pawns, and then I have the number cube 3. If I have a blue pawn here and I have 9 more, how many total do I have? 10 x's. And then I still have that number cube 3, so I add that on. It's not always going to be addition. We will have a little bit of subtraction. In this particular problem, I'm starting with 7 m's, and then I'm subtracting 2 m's away. So again, all I have to do is subtract those coefficients because my variables are the same. So when I have 7 m's and I take away 2, how many do I have left? Julian? 5 m. Very good.
Hello, people.
I'm going to wait to do that. I'm going to wait to do this one. I'm going to skip that problem and come back to it in a second. Let's do this. All right, now we're combining some skills that we've learned this week. We're combining like terms, but we're also using distributive property. So we want to add all these together, but we can't add them together until we get rid of the multiplication. Please excuse my dear Aunt Sally. In order to add these, we're going to have to multiply it by. So we want to add these together, but we cannot combine those two because they're two different things. So we have to do what we did yesterday and use our distributive property. 3 times x, and then 3 times 2. Our x is going to transfer straight down. We're going to add to it 3 times x, which is 3x, plus 3 times 2, which is 6. Now we can combine our like terms. And when we do that, we have a blue pawn here, 3 blue pawns here, number cube here. X plus 3x gives us 4x plus the 6. I'm getting the sense that some of you are slightly bored. Try that one on your own. All right, in solving this one, anybody think they got it? Sammy?
2y plus 21.
No, not exactly. Aiden?
Oh. Is it 4 to 1?
No. Natalia?
6 times 3y.
No. William?
Oh, 2y plus 14.
Mm-mm. Brian? No. Toby?
3y plus 18.
Mm-mm. I think I'm seeing what's happening here is we're failing to see exactly what's happening. Order of operations. You're starting with this number cube 5. You're taking away 3 of those. So think about what that means. You're starting with the 5. You're not taking away 3. You're not even just taking away 3 y's. You're taking away 3 y plus 7s. That's y plus 7, y plus 7, y plus 7. Remember earlier when I said I always change subtraction to addition? This is one of the reasons. Because you're not just taking away the 3, that subtraction has to get distributed to both of those. So when you do this, it'll be 5 plus the y's. You're taking away 3 y's, and you're also taking away 3 7s. This subtraction applies to all the y's and to all the 7s. You're taking all of that away. So you have to distribute that subtraction. We do that through the negative. Negative 3 gets distributed to the y, negative 3 gets distributed to the 7. Now you can combine your like terms just like normal. Here's your number cubes, and here's your blue ponds. So I've got 5 plus negative 21. Is that negative 16? So negative 16 plus negative 3y. Try this one. Try that one on your own. Anybody think they found it? Natalia? Good. Now, in this one, notice our variables. We actually have 3 different kinds. We have our x's, which are like blue ponds. Then we have y's, which are not blue ponds or number cubes. This is an x, so it's like a blue pond. Here's our 5, which is just like a regular number cube. And then we have this minus y here. You combine all the things that match. I got a 3x plus another x. That gives me 4 x's. I've got 2 y's, and then I have to take away a y, so that gives me 1 y. And then my answer, or and then my number cube there is a 5. So in this one, you've got 3 different, it's a 3-term, it's a trinomial. All right, what I'm going to do is put a bunch of problems on the screen. I'm going to start with the easiest ones, and I'm going to end with the hardest ones. Now what you're going to do is you're going to start with the easiest ones, and then I'm going to allow you, once you do one of the easy ones, you can skip to then whatever level of difficulty you choose. All right, so there are your problems. You have 8 problems. Start with either 7 or 8. and they increase in difficulty. 13 and 14 are probably the most difficult of them. What I want you to do is start with 7 and 8, and then I want you to choose your difficulty level past that. There are 8 problems. I want you to do at least 6. So there's 2 of those that you don't have to do. You decide which 2 you're not going to do. All right, so when you add those together, you've got 2x's plus 5 more x's, so together that is 7x. Sometimes it helps to actually circle your terms so that you can really identify the coefficients there. For number 8, you've got a y, and then you're adding 10 more y's to it. Remember, if it's just a variable by itself, the coefficient is going to be 1. And when you have 1y plus 10 y's, it gives you 11y. Just like that. For number 9, again, identifying the coefficients here, I've got that term is 8. I've got an x here by itself, the coefficient 1. Then I'm taking away 5 x's. So my 8 stays. And then I've got a 1x, but I'm taking away 5 x's. So what does that leave me? Aiden?
8 plus -4.
Yeah, plus -4x. For this one, I've got my 8y. And then I have a -7 plus a 7. My y's, there's only one of them, so that stays. That y term stays. But what happens here to my 7's? Alexis? Yeah, that's exactly how I think of them. I've got 7 negatives and 7 positives, so they make 0 pair. So those cancel out. So your answer here is just 8y. Now the distributive property ones. All right, let's look here at our distributive property problems. First thing we're going to do is look here. Oh, well, we can't add everything together yet because we have distributive property. Have to get rid of the distributive property first. We're going to go 3a and then leave that as a plus. And then 3 times 2 gives me 6 plus 2a. Now you can combine my terms. Here I've got 3a's. Here I've got my number cubed 6. Here I've got 2a's. So when I add everything together, 3a's plus 2a's give me 5a. And I've still got that 6, so it's 5a plus 6. If you have 6 plus 5a, it is the same thing. Commutative property, the order that you write those does not matter. When I do problem number 12, distribute. -3 times z gives me -3z plus -3 times 2 gives me -6. And then I've got a minus z outside. So I've got -3z plus that -6 is a number cube. And then I've got -z. Remember the coefficient of that being a 1. -3 minus 1 gives us -4z. And then the -6 stays intact. Number 13, we're starting to get to the more difficult of the problems. Distribute your number -2 plus -2 times 3 gives us -6 plus -2. And as you can see here, you've got a -2x and a positive 2x, which tells you that those are going to cancel each other out. You're starting with -2, you add positive 2 to it. Those two cancel, leaving you with a -6 as your answer. The last one, number 14. Remember that this is all being subtracted from 8a. So you're going to change subtraction to addition, make that its opposite. That's the only time that I'm going to demand that you do that. Now, when you distribute, you're going to have 8a plus -2 times a gives you -2a minus -2 times 7 gives you -17. Oh, I'm sorry, 14. I know what I'm doing. 14. And then when you add those together, 9a plus 14, or I'm sorry, 9a plus negative 2 gives us 6a minus negative 14. And we said already that a negative and a subtraction next to each other look really strange, and it's probably easier just to change subtraction to addition. The next number is opposite. So your answer here is 6a plus 14.